Hi everybody, so this is the class example. If you're in my class, I'm Dr. Dickerson, that you guys asked me to do a video on this specific example, so here it is. Okay, so we're going to give the IUPAC name for this compound. And we're just going to use the same rules as we always do. We do see that it's a hydrocarbon, even though I do have a double bond, so I have an alkene in my compound. That does not take precedence over finding the longest carbon chain, so that's what we're going to start with. So if I start, let's just say going from left to right, I get 8 carbons, but let's make sure that my numbering is correct. So I'm going to check the other way just to see what we come up with. Okay. Oh, goodness. Okay, there we go. 7 and 8. All right, so I hit my first substituent at 4 on this way, and then I hit my first substituent 3 this way. Okay, so that tells me that I need to number from right to left. So I'm going to get rid of the left to right numbers since that is not going to give me my lowest substituent. So here is my parent chain. And then I see I have 3 substituents. We're going to start with the easier ones, which is going to be on carbons 3 and carbon 4. So carbon 3 is just one carbon coming off, and I know that's a methyl group. So here I have a 3-methyl. And then if I look at carbon 4, I see I have 3 carbons, but I'm not going to name this as a propyl group because it is split where it is bonded. What do I mean by that? Well, if I were to number these, I'm connected at carbon 2 and not carbon 1, where I would expect to be if this was a propyl group. So that tells me that this is an isopropyl group. So specifically, we're at the 4 position for isopropyl. Okay, now for this next compound, we're going to name this as if it is a mini compound because I don't have a common name for this specific substituent. So therefore, I'm going to treat it like a mini compound. Okay, so again, I'm going to look at for my longest carbon chain. So I see that's 3 carbons. And I'm going to number it starting at the pi bond because in this mini compound, that double bond is part of the longest parent chain. So it needs to have priority over where it has the lowest number. So here's my mini compound. It has 3 carbons. I have my pi bond represented. So I know previously if this was just an alkane, I would name this substituent as prop and propanil. There we go. But because of the fact I have a double bond, I'm going to change this name where I get rid of the AN and I replace it with EN. So I have propanil. All right. So that's the name of my parent chain, but I need to add some numbers to this. One of the things I need to add is where that double bond is located. So the double bond is located at carbons 1 and 2, but I'm only going to reference one of those, and that is going to be the carbon that has the smallest number, which in this case is 1. Now, because of the fact it is 1, I don't have to put it in my name, but it's good practice because we're not going to always have it to where it's implied like that. So I need to add the 1 where my name tells me there's a double bond, and that would be the N part. So I'm going to add that 1 right before the N. So now I know where my double bond is. Another piece of information I need to add is where the real parent chain is bonded to my mini compound, and that's bonded right here at carbon 2. And so I'm going to add that right before the part of the name that tells me that this is a substituent, and that's going to be the il. So here is my 2-il, and I've now accounted for everything in my baby compound. So that's the name, prop1n2-il, but it's still a substituent off of the large off of the large parent chain. So I need to know where it is off of that, which we already know to be carbon 5. And that number is going to be in the very front, in front of the parentheses. So there is the complete name for the mini compound substituent. So now what I want to do is I want to combine all of my substituents and my parent into one name. And to do that, I'm going to look at the first letter of all of my substituents and see which comes first. So I comes first before M and P. So I have a 4-isopropyl. Now M versus P, LMNOP. So then my 3-methyl comes first. Then I have my 5-prop, 1N2-il. And then my parent chain had 8 carbons, so that is going to be octane. And one question a lot of people ask is, why is it octane when there's a double bond present? Well, the double bond is already represented in my name right here. The actual true parent chain does not contain the double bond. So therefore, I'm going to keep the alkane ending in the parent. Okay.